Okay, part B. Write an equation for the line tangent. You're right there. I always draw my favorite picture. Stop right there. Write an equation for the line tangent. So I draw this picture, and I remember that this is the equation template for the line tangent. Now I keep reading. To the solution curve. Remember, the solution curve is the formula y or f of x. That's the solution to the differential equation. So that's why I labeled this as f of x. Write an equation for the line tangent to the solution curve in part A at point 0,1. Stop, there's a period. So I need to do that. So I know the point here. So easy problem. Y must equal slope x minus the x-coordinate where the line is tangent plus the y-coordinate where the line is tangent. Technically, this is any point on this red line, any point. I just happen to know one of them. The one you usually know is the point of tangency. So, we have most of our equation. We need a slope now. So we need to know the slope of this red line. We need to know the slope of this red line. But because the line is tangent to f, the slope of the red line is exactly the same as the slope of f at this point. Well, the formula they gave us, dy dx, that's how you find the slopes of f. So I want to write down the slope of f at a point 0, 1. That's got to equal whatever this formula gives me when I plug in 0 for x and 1 for y. Cosine of 0, I look at my watch. Angle 0 is right here. Cosine of 0, cosine is across. That's 1. So 3 minus 1 is 2. 2 times 1 is 2. So now I know my equation of a line tangent is going to be y equals 2 x subtract 0 plus 1. If I write that, I will get 1 point. On an F Frq, I actually don't even have to find the value of the cosine. So I could have just written 2 multiplied by cosine of 0, like I did here, times the x minus 0 plus 1. That's the same thing. You get the point as well. So that's 1 point so far. Use the equation to approximate f of 0.2. Here's where x is 0 on f. That means we are visualizing the idea of going to this spot on f, over here. Let's clean this up a little bit. Okay, so we're visualizing the idea that here's where x is 0. That means this might be where x is equal to 1.2. And we're trying to find this y value here. Like if this is a graph, I'm trying to find this y value. That y value is f of 0.2. This right here would be f of 0.2. But we're not supposed to find that value. We're supposed to use the tangent line, use the equation of the tangent line, use the equation of the tangent line to approximate f of 0.2. So what we're going to do instead is, instead of finding the y-coordinate of that blue dot, so instead of finding the y-coordinate of this blue dot right here, which would be this y value, we're going to go find this y value right here. That will be our approximation for that y value. So remember that this equation here, y equals, this is how we can find any point on the tangent line. So all we have to do is write down f of 0.2 is approximately, not equal, is approximately 2 multiplied by. The x-coordinate we're using is x equal, oops, I wrote that wrong. This would have been 0.2, not 1.2. So you plug in a 0.2, subtract 0, add 1, and then we just stop. That's how we find an approximation for f of 0.2. That will earn us the second point. Here in green, I'm showing that. Green, I showed just leaving the formula with 2 cosine 0, but either way. So this is actually 2 total points for that problem.